Oh hey, it's Wes. And, well, you've probably heard Apple has announced some new MacBook Pros. Not only that, new chips. I want to talk to you about 5.5 reasons why Apple is going to make a killing on these new MacBooks. Some of them might not be as obvious as you think they are. So, first of all, I was thinking of buying one and doing a review series, but then I realized I don't have enough money to do that. Hopefully this channel continues to grow so that I can do that someday, because I would like to do some real-world testing on these, because there are too many channels that are just doing single-purpose and synthetic testing, and it's just not all that helpful to us. So let's get into this. I'm going to go through the more obvious stuff at the beginning, but then at the end we're going to talk about some really interesting stuff where Apple is saving a ton of money. Number one, not all of the parts being used on these are as pro and top of the line as we think they are. Okay, first things first. These things are very high quality. I don't care who you are. These are some very high-end products. The screen's spectacular. You've got incredibly state-of-the-art HDR displays, nice rigid chassis, enormous amount of throughput, and we'll find out from the synthetic benchmarks that these things just blow the doors off of any other mobile devices. They'll even blow away most PC non-mobile devices. But not everything in there's stellar. Let's have a look at the HDMI port. It's only 2.0, which I find frustrating because this thing boasts the ability to drive a tremendous amount of external displays and a tremendous amount of external pixels. But an HDMI 2.0 port is only going to give you 4K 60, whereas it has the ability to drive 6 and 8K displays through the Thunderbolt ports. So when you use the dedicated display port, you're getting the worst display experience. That's a little bit frustrating. They could have put an HDMI 2.1 port in there, and then we would have had some really powerful output, but they didn't. They cut a little corner there. The one that really gets me, though, is the SD card reader. It is only UHS 1, which for a lot of people is sufficient. But for professionals, like myself, when I ingest an SD card into my computer, I'm looking at like 90 gigabytes of data that I'm pulling in. And having a UHS 1 port is going to waste probably a half an hour of my time versus some really fast UHS 2 reader like this ProGrade reader right here. That'll get it in way faster. UHS 1 moves about 90 megabytes per second. This thing can push almost 300 megabytes per second. That's a pretty big difference and a pretty big time saving on my part. And last, the webcam. Oh, that is a little bit controversial, isn't it? It's got a notch. But the notch is not a problem in and of itself to me. What gets me is the size of the notch. It's huge. Compared to the notch on my iPhone, look, it's a teeny weeny little notch right up there. It's only, what, like 3-4 millimeters? The one on the screen of the MacBook Pro is even bigger. But the one on my iPhone contains a full host of Face ID sensors and a much better camera. So we have a bigger notch and a worse camera. Now, the camera is better than on the old MacBook Pro, but that's a pretty low bar. They say that it has to be, you know, pretty crappy anyway, just so that you can fit it inside the display. That might be. My iPhone is thicker than a MacBook Pro display lid. So I give them a partial pass there, but if I had to guess, I would say that in the future, they are planning on putting Face ID in the top of that, and I would even hazard to guess they were planning on putting Face ID in this version, but they couldn't get it thin enough in time to fit it in there, so they already had that cut out. And then next year, when they put Face ID in there, and everyone wants to upgrade, the notch at the top of the screen won't have to change size. It's already ready for that. All right, so that's number one. They cut some corners on some components. Number two, pent-up demand. There are so many people with the classic MacBook Pros. And by classic, I mean the generation before they chopped all the ports off and made it super thin. They have been waiting and waiting and waiting for something new, and this is it. There are so many people out there that have been waiting for this update, hoping that it would come. And I don't want to totally throw Apple under the bus for the previous generation of MacBook Pros that weren't great for everyone. The thermal constraints of this MacBook Pro had a lot to do with Intel's issues. Intel had promised Apple certain mobile processors with certain TDPs that would function fantastically inside this new thin generation that they had released. But Intel didn't produce those chips. The die shrink to get that thermal constraint is only happening this year, finally. That must be enormously frustrating for Apple. So all these people were waiting for a new MacBook Pro, and finally it is here. They have been sitting on some money. Unfortunately, I have not been sitting on some money. And it's finally time to get this computer that they have been waiting for. And there you go, they're gonna sell a ton of them. Number 3, making their own chips. So how does producing their own chips make them money anyway? Well, let's have a look over here. Buying the chips for the last gen MacBook Pro cost them hundreds and hundreds of dollars. These chips that they're printing with TSMC probably cost them at most $100 to $200. Not only are they producing a ridiculous number of the same chip, which has efficiencies of scale, but they're not having to pay a markup to Intel, to AMD to get these going. So let's get into the really interesting stuff right now. We all know that the world is going through a chip constraint, a supply constraint on electronic components. Car manufacturers can't get their cars out because they can't get chips in there. One of the reasons for this supply constraint is actually Apple. And not for the reasons that you might think it is. They're not nefariously buying up capacity. It's that they knew that this chip revision was coming and they were going to swap all the chips out. They were going to get rid of the Intel chips and they were going to produce their own chips. A tremendous amount of them. And so years ago, they had this plan and they bought up the high-end modern manufacturing capacity at TSMC, quite possibly the main modern chip supplier in the world, and they reserved it. And then everyone else, unfortunately, is fighting over the scraps. So even this new M1 Pro and M1 Max chip, this was already reserved a long time ago before the chip shortage. Apple is still running on existing contracts. They don't have to fight to produce more chips like a lot of other companies do. They were ready to go already. And so, number one, they don't have to pay inflated prices to barter for extra manufacturing capacity like other companies do. They're still running on the prices of their original contracts from over 2 years ago when they booked processing for these chips. Now, they invested a lot of money in upgrading the production lines at TSMC to make this possible, but even with that investment, they're producing these chips at a bargain because they're not competing with the current supply-constrained global market. That's fantastic for them, not so fantastic for everyone else. Even Intel has looked into having their chips produced by TSMC, but it's going to take a long time to get that going. All this stuff takes a long time. Fabbing chips is not easy. Which brings us to the next thing, part binning. When you're fabbing a chip, and you've probably heard this before, if not, let's talk about it. I find it super interesting as I'm an electrical engineering technologist, and I studied this stuff in school. There will always be imperfections of a certain percentage on the wafer that you print. And Apple has taken full advantage of the standard way of dealing with this. It's called part binning. You have two options essentially if you have an imperfection on the chip. Either A, you toss it in the garbage, or B, you clock it down until it does work, or disable those particular components in the chip. And these M1 chips are specifically designed to optimize the process of binning by using multiple similar components, such as matched CPU units and matched GPU units. What does the word binning mean in this context? Well, it literally means you're making a bunch of the same chip, and then after testing and validation, you're putting them in different bins for different product streams. So let's take a closer look at the ordering page for these MacBook Pros and see how that works out. Now, right from the get-go, you'll see you have an 8-core option or a 10-core option for the CPU, 14-core or 16-core for the GPU. And what that is, it's actually the exact same chip. Apple's not making two different chips, or TSMC, depending on how you look at it. It's the same chip. So when we have the 10-core CPU, 16-core GPU chip that is printed on the silicon wafer, if up to 2 of those CPU cores have aberrations or damage in them, they can just disable them. The chip is designed to be able to ignore those cores and just keep on rolling. Same for the GPU. If up to 2 GPU cores have an error in them, just cut them off. You tell the chip, don't access them. Works fantastic. And so instead of having to throw away wafers, throw away chips, they can still use those chips and still sell them to you. We see a lot more options going on here. And honestly, there were more options than I expected to see. So if we select a computer and go in, we have 16 core, 24 core, 32 core. And so when we get into the bigger Max processor, M1 Max, there's a maximum of 32 core GPU, but they can have up to 8 of those cores faulty on the chip and still ship the 24 core GPU version. That's a tremendous advantage for them. So there can be a ton of errors, a ton of imperfections on the silicon, and they can still ship it out to you. Now you might have heard that the RAM is built in on an M1 Mac, but that's not exactly the case. This is a part of a chiplet design. The RAM is added on separately, so if you have a bad RAM chip, that can go in the garbage. It doesn't ruin the CPU, GPU chip. So those are all separate and they combine them at the end. So again, that gives them more versatility. So with this part binning, they have a tremendously lower amount of loss. And last, there's a bonus offer on this one. As soon as I saw the lithography of these chips, I had a suspicion. And this was based on information coming out of Apple early on when we heard about the develop on this. The two chips were referred to as Jade C die and Jade C chop. Jade C die is our M1 Max chip. It's the entire die. Jade C chop, I can't confirm this 100%, but I'm not the only one who has noticed this, appears to be the M1 Pro chip. Yes, once again, there isn't even 2 chips here as far as anyone can tell. There is one M1 Max chip that if they have a bunch of GPU cores with imperfections in them, they can just chop that right off, and then it becomes an M1 Pro chip. And if that has further imperfections, it becomes a lower-end part-binned M1 Pro chip. They have so much versatility in this design. They only needed to buy one chip. Now think about that. A lot of other companies, they have multiple chips, multiple SKUs that they have to maintain, and then you have to try to determine what the demand for all these chips are going to be. If Apple ends up selling M1 Pro chips like crazy, then they might just take some perfectly good M1 Max chips, chop the end off them, and stick them in the laptops. They have that option. With reduced SKUs, there is reduced manufacturing cost, reduced startup cost, and reduced inventory costs because they need to track fewer objects. This is a brilliant move, and it's going to make them a ton of money. Now, I'm not arguing that what is in this computer is dirt cheap. That display is very expensive. But Apple has done this smart. They have played the long game, they have ramped it up slowly, and they are ready to make a buttload of money on these MacBook Pros. Maybe one day I'll own one when it hits the refurb store. Let me know if you have any questions or just have any comments about this down in the comments below. Please keep it clean. We don't really need this Apple versus PC stuff, at least until the benchmarks come out comparing Apple and PC. But until next time, let's go take some photos.